Hi, radio is adopting new technologies and practices from the IT industry for its own success. But what exactly does a virtual air chain look like? My guests are Roz Clark, Philippe Generali, Alan Jurison, and Greg Shay. This is a topic that you may have questions about that go beyond our format today. So I welcome you either to use the chat to raise them or to email me at radioworld@futurenet.com. I'll share them with our guests, and I'll give you that email again at the end. Roz Clark, let's dive right in. You're the Senior Director of Radio Engineering with Cox Media Group, and you're on the NAB Radio Technology Committee, where you're chairing a group that's working on next generation architecture. So can you start us off with an explanation of what we're talking about, the concept of the virtual air chain?
Thanks, Paul. Yes, really the concept of the virtual air chain needs to really discuss what is the air chain, and that really is all the functions and the processes of a radio station, as well as the interconnectivity between those different systems. So I have a really rudimentary block diagram here to sort of display what we're talking about and what can be virtualized or software and how they're interconnected. And so this very simple block diagram is assuming that everything is like an old school radio station. Everything's at the transmitter site, which is very unlikely. Things are spread around the network, and interconnected studios and transmitters are displaced, et cetera. However, this particular diagram does attempt to show what can be software today. A lot of work has been made in that regard, and then how they're connected. So you can see as you go from left to right that a lot of things already can be software, which means if it's software, it can live somewhere. Even the console, the mixer, which I won't get too deep into, but that is generally a piece of hardware, but it can be software, a mixing environment, if you will. PPM encoding, there have been movements made in the industry as we speak to get that able to be put into an appliance as software and not necessarily a hardware device. The same with EAS, which will be discussed later. Audio processing, I think we're fairly familiar that can be software based. And of course, a transmitter has to be hardware. At the end of the day, you have to hit a piece of hardware to transmit a signal. But as you'll see, the signal flowing across, if you have everything in software and you have everything in a network, then you can talk about where this will be. But as it is today, we have a challenge that some of the virtual air chain has to come in and out of a network to hit appliances such as the items that are shaded in what on my screen looks like a pink color. This next slide is just really quick high-level overview. If things are compiled and put into a network connection, then the location can become somewhat agnostic. There is some components here, there's some technology that has to be developed and standardized so that this transport mechanism can have a placeholder, if you will, for all sorts of content to live within it. And that way, as the network is transmitting and interacting with the next component of the air chain, there is an expectation that there is some compatibility with whatever process or whatever system needs to reside next. That's a really high level overview, but what I'd like to leave the group with before we talk in greater detail is that interoperability and intercompatibility between these building blocks of an air chain and how they talk to each other over this network connection is key and vital as we migrate and evolve from the present hardware dependency into a software dependent system. That's all for now.
Okay, we'll come back to some of those details. Philippe Generali, RCS is a software company. You make automation and other radio workflow products. So how does this conversation translate for you?
So we want to try to focus here for this particular conversation, Paul, and thanks for having me, by the way, but on two key features that are usable today. This is not something that is the future. This is not something that is a pie in the sky. This is virtual offering that you can use today at your radio station. The first one is the cloud development that we've done, which allows you to have a disaster recovery workflow. And the second one, which I'm going to go to in a minute, is the To-Go initiative. We started the To-Go initiative developing mobile access on a browser in February 2012. So we're in our 10th years of the To-Go effort. Let me go on the disaster recovery workflow briefly. So as Ross was saying, various parts of the chain can be software based or hardware based, on-prem or somewhere else. What we developed at RCS is completely cloud-based disaster recovery workflow. And when we say disaster strikes, it's essentially viruses or anything that will push you out of your studio, out of your normal on-prem software utilization because they're incapacitated in some way. So in a brief description, the normal workday users create their audio, their logs, their voice tracking, and everything is saved locally, but it's also automatically saved to Zeta Cloud. That Zeta Cloud software reconfigured in the cloud, your entire working system, cloud-based. There is no hardware anywhere. We use containers and all kinds of software to control the various moving parts in the cloud. And then when disaster strikes, because, for example, there is a virus at the station, and by the way, I don't know if any of the people listening to us or you guys here on this great conference call have had to deal with the virus, but it spreads in minutes on every single Windows machine on your network. So you can have a redundant center, which is belt and braces with the same hardware, same software on the side, ready to go. It will get infected. And in case of ransomware, there's a wrapper around your audio assets. And then you receive a note saying, hey, give us so many Bitcoins and we'll unwrap your software and can play. So because in the cloud, we're talking about Linux software, this is completely protected. So you go to your browser, start your emergency system. It will completely play your music with your segues, with your commercial, with your voice track. It will go straight to your internet stream. And you know what? By the same token, we'll do a high quality stream that will go to your transmitter and you're out of the woods. And now you can turn off all the machine on your network everywhere, including your WAN. So if you have a multi-city, we had a client who had dozens and dozens of markets, and they have to turn everyone off at the same time. Not one machine can be left on. Then you run your antivirus and so forth. And then when you're ready to come back, we'll gently restore the database and you're back in business. So this is the cloud system, and this avoids having to have a separate system. And it's like an insurance policy, if you want. Completely transparent and allows you to stay on the air. The second one is what we call the to-go line of feature. We have selected to-go, which is our music scheduling. And what we wanted to create back there 10 years ago was a way to control the software on a browser so that people can do it on their phone, on their tablet. I had the idea because I was talking with a friend, program director in Europe, and at a dinner he said to me, "Oh, I just received an email with the log for tomorrow, so I'm reading to make sure my MD has done the proper log, and he's reading an email with the log inside." I said, "Wouldn't it be cool if you had an app that would allow you to move around the software and move around your songs and everything?" So we went on the to-go series of app, and Zeta to go is just that for your automation system. You can control your automation system from wherever you are. You can voice track from anywhere. You can control your on-air operation. You can manage the content, add songs, singles, and so forth, and you can monitor your cluster. And that has been, of course, with this pandemic, a lifesaver for many of our customers who have sent us nice picture of how they use the software. Look at this dad here. He's voice tracking with Zeta to go on the right-hand side, and he's got his two kids on his laps, and they love broadcasting. So today, all those things are available, real, and not science fiction.
There's the new world of radio in a picture right there. Thank you, Philippe. Alan Jurison, Senior Operations Engineer for iHeartMedia. You're working closely with these topics, and you're involved with Roz on the NAB Radio Technology Committee. Tell us about what that committee is doing.
Well, we've been working on a variety of different things. One of the things that Roz mentioned is, trying to make EAS a little more flexible in the air chain in this new world. And one of the things that we've worked with the hardware manufacturers of HD gear and also Xperi is adding the ability to insert emergency alerts into HD subchannels, such as your HD2, HD3, HD4, with a single, the existing EAS encoder you already have for your HD1. It's been kind of cumbersome the last 15 years to be able to do that. You've always had to have, a master EAS encoder, decoder, and usually use some sort of audio switching device to kind of interrupt the audio. And that's been an issue for broadcasters such as iHeart that want to originate HD2, 3, or 4 subchannels, outside of the market. We have a wide variety of different formats that we have on iHeartRadio. We like to feature them on our HD2 and HD3 subchannels throughout the nation. But the issue is that automation system is not located, that's running that national format like an 80s or a 90s format isn't necessarily running in the market. So how do we get emergency alerts in it? And essentially, we've paired together. 2WCOM has made the first device, and it's called the HDRCC. And you basically tie together the GPIO from the EAS, like your NDEC, your Sage NDEC, or your DASDEC, or whatever your EAS solution is, and the audio from that device. And when an alert is active, the 2WCOM device connects into the exporter, which is now the new embedded importer exporter in Gen 4. And essentially, it interrupts any audio capture clients from coming from wherever they may be. They may be a local capture client if it's all within the same market, or they could be external capture clients running all over wherever you may have IP connectivity. And this kind of shows a diagram of the alert in process. So the EAS is up here on the left, it triggers and the audio is fed to the 2WCOM device. It goes to the importer exporter, interrupts the audio clients, and goes over the air through the EDX stream on all channels. So it can do it on the HD2, 3, and 4 simultaneously. Or you can mix and match. You can have the device only do HD2 or do HD3 or 4. It's however you'd like. On our next slide, here's a field test that we've been doing. So this is the iHeart 90s format. It was running on, it's moved up to what we call Zeta Cloud now. But in this original thing that we've done, it was just a standard automation system that was running in our Cincinnati data center. And it was running, NextGen and a music log and our streaming software. Well, we spun up a copy of the new Gen 4 audio capture client and pointed it through our WAN infrastructure, which goes from Cincinnati to San Antonio, out here to Syracuse, to the studios. To normally the path goes from the audio, where the audio source is, it goes all the way through the STL and into the Gen 4 importer exporter. That's how it gets on the air, the music that we hear all the time. And then during an alert, though, the EAS encoder is located in the market, and has the required local configurations. The EAS encoder gets the alert and triggers and sends that alert essentially to the 2WCOM device, which then uses that same network to get up to the transmitter site and essentially interrupt the audio that's coming from Cincinnati, or as actually today, since we made this slide, this station's actually migrated up to a cloud-based playback system. So we're able to still do EAS insertion, even though that audio doesn't reside. Before it was residing and being generated in Cincinnati, and now it's actually being generated up in the cloud since this slide deck was put together. So it's pretty exciting stuff to be still be regulatory compliant and still offer those EAS alerts, but have that audio come from literally wherever you'd like. And just kind of going in part with what Roz was talking about, we at the NAB RTC, the Radio Technology Committee, been working with the manufacturers and such to do PPM encoding built right into your audio processor or appliance. So audio processing's kind of been software-based. PPM is now being part of a software module. There's several tests from NAB RTC members that are field tests, and it's all the major audio processing manufacturers are part of this. And we're also starting those discussions similarly with maybe making EAS a little more flexible as well. So that's kind of some of the work that the NAB RTC has been doing. We've been working with Roz and a lot of our other partners at Cox Media and New York Public Radio has been involved with this quite a bit. Entercom and Bonneville and quite a few others too.
It's really interesting to see these concepts that we've been talking about start to be play out in these specific use cases. Thank you.
Like that. Yeah.
Yeah, I like that slide. That's really telling.
Mm-hmm.
Greg Shay, I know Telos Alliance was already active in virtualization, and in the last couple of weeks, you've rolled out a couple more products with virtual in their name. So, what's the view on this from Telos?
Yes, let me go to full screen. Okay, thank you, Paul, and thank you to everyone else. This certainly is a timely topic, and if I may. We've been talking about all the ins and outs of really what needs to be done, but what I'd like to do, and I know this is kind of backing off and going more general, but I'd like to put a really sharp focus on why are we talking about virtualizing this and virtualized software. And it's not just because we're copying the IT industry. The point is, why did the IT industry evolve to virtualize software? And again, these are really basic, concrete things, but this is the reality that everybody has to live with and staying on the air. It's basic things. Hardware is fundamentally unreliable. Human labor is expensive. Whatever you have to do, react, reroute, reconfigure, or repair. And then you start to get into, like I said, with the IT industry, when they're serving millions and billions of customers, how do you make progress on this, and how do you get the operating costs down? And one of the fundamental things that drove to servers and virtualization is because it's less expensive to have many copies of the same device than to have a bunch of different special purpose things. So again, just the basics, but it always helps to keep this in mind. Why are we doing this? So when you used virtualized software, you solve those very real world problems you get on the fly automatic replacement of failures from a pool of identical resources. And this is done with scripting. This does not have to be human involvement. Somebody has to set it up for sure. And with that automation, it means there's less labor. If you have hundreds or thousands or millions of operations in the case of the big web operators, there's no way you can have human intervention even to look at each of those. But here's what's important for broadcast. We can shorten the fault response time, and you can be prepared, because the classic story I always talk about is the guy that has to get out of bed in the middle of the night and get the station back on the air. But if it is set up for automatic failover and automated recovery, then you can have the system recover before you even knew it was down. Orchestration of the pool of resources that get deployed as needed. This can be fundamental for OpEx. Instead of having to buy 10 of these and 20 of those and spares for each of those, you're buying into a pool of resources in those servers, which are able to be used for different things. So if on one day, you have a different mix of what you need than the other, it all uses the same investment that you've made. And your spares are spares of the generic server, not a couple of each, different kind of thing. So all of this gives you this improved operational efficiency in your operations, your configuration, maintenance, and monitoring. So I'm just trying to make the point that this is more than, virtualized and in the cloud, these words we use. It isn't just the flexibility of being anywhere, but you really have to look at the ramifications of what does that really mean. So the result is that we can deliver the highest reliability for the lowest economic cost. And you can't ignore that. Like I mentioned, the end goal for us as broadcasters is the benefit of a system that detects and recovers from a failure before we even knew about it. And this is the way the world works. The banks and Google and Amazon and Netflix and, all of these people. In fact, here's my main point. The more mission critical that a function is, so here we're talking about our air chains. That's probably the most fundamental, core of what we have to protect. Well, the more critical that air chain is, the more we need to do it this way with virtualized software. This isn't, this is one of my main points. Virtualized is not a fad. It's not following IT because it's the latest thing. Virtualized software is actually the best way to engineer the air chain. So this is just a picture of what we're doing right now at Telos Alliance. We have a broad product line, through the companies that have come together really end to end, all the way, from microphone processing and, audio over IP nodes on the left-hand side flowing through mixing, program delay, watermarking, processing. Over here on the right, we've innovated the FM multiplex over IP, which can go right to the transmitter. And we're also very involved and interested in the NAB developments on standardizing that. We've got intercom, telephony, all this stuff. So here, the green boxes, these are the products today that we've released as software. And you'll see more coming. So we have this strategic investment in enabling software virtualized air chain. That's all.
That's a telling slide right there. And I appreciate the high level view that you provide on why we're doing this. It reminds me, I had a conversation with Roz a couple months ago, and I said, is the industry ready for this whole concept? And Roz, you said, absolutely. From a business case, cheaper, better, faster, which I thought was a telling quote. But Greg, let me ask you, and I apologize in advance that, for the 6 or 7 minutes left to us, but I'll ask everybody to answer in 30 seconds or less. But Greg, are there concerns about putting too many of our infrastructure eggs into one basket, or the hands of people and companies that are not under our direct control?
Well, we always have the choice, and I try to avoid using the word cloud. I find it better if we say virtualized software on servers, because as the broadcaster, you can always build your own server resource on your own premises and make it completely secure. And there are major customers that are doing exactly that. And there are banks that do that. This is not an uncommon concern. And the point is, you have that choice. For us as the developer of the products, if we deliver it in that format, it still enables the customer to do what they choose to do.
Mm-hmm. And Philippe, you introduced us to a couple of very clear use cases with disaster recovery and the remote access across your workflows. So where do you see this going further? I mean, how much further down the road will you go, and does the industry go with this toward total virtualization?
I think it's an enterprise-wide transformation that a broadcaster has to go into, because when you virtualize your environment, you're going to replace most of the time CapEx by OpEx. So your ongoing costs for operating expenditure have to be, because of that virtualized environment, have to be compensated by a reorganization of your engineering and of your real estate. Do you need rack rooms, and how much do you need them, and so forth. So you need to rethink your enterprise. Once broadcasters and webcasters, but they're already there, but once the company is ready to make the plunge, there is no limit. You just redistribute the allocation of the cost, and you rent things, and you rent software, and you rent storage space, and you rent everything. You rent your services basically, and then some of that cost gets offset by a lower cost in other part of operation of the company, which will compensate for that. So it's a shift that will be that has started, but make no mistake, it won't stop. it will end all the way. And there will be a profound transformation of the way a radio station is run in the very near future.
Well, Alan, I would have to think the term profound transformation also applies to what the job of a broadcast engineer is. You've been doing this a long time, and you and your colleagues as engineers, I think, have to think about their professions differently.
Yeah, I mean, that's part of it too. The good thing is it's kind of a marriage of something we've been doing for 20 years, which is bringing, audio along with IP. Instead of us doing it necessarily in computers now, a lot of this is being moved into software processes that run on any computer, or really where we get the reliability of all of this is in embedded appliances. So, you look at where success has been. We talked about audio processing being in software. That's been going on for 15 plus years now, and all the major broadcasters have really good, reliable software that rely not on a Windows computer, but on an embedded appliance. And we're seeing more of that. And supporting that is actually easier because when it's an embedded appliance, it's more reliable. They're all set up to do remote access as well. So I think, from a skill set, it definitely, for those that are used to some of the, the older wiring methods and stuff like that, a lot of that stuff translates well into the new environment as well. It still has to be wired up and configured, and it still needs to be maintained. But you can do it from further away. You don't have to be right there necessarily to fix all of the problems.
Roz, as you present these concepts to people in the industry, I'm sure there are certain questions that emerge that you've heard more than once. What are the concerns or questions that you're hearing from people, technology savvy managers, about these concepts?
Yeah, so I think fear is a great motivator. And there's this idea that if I can't walk up, I've heard this comment, I can't walk up and I can't put my hands on it and I can't touch it and I can't sniff it with a monitoring tool and hear it or whatever, then it's got to be bad. In fact, though, if you think about it, this call we're on is a Zoom call. I'm at home on a house regular internet service, and I've had no glitches with audio and video so far. And so the technologies that surround us as broadcasters, we really should become more and more familiar as well as competent in how to utilize them. I think broadcast engineers, by definition, at least in my experience, have been the ones who are super creative and know how to manage the technologies that are introduced to us. The manufacturers, of course, are subject matter experts, and the things that we have, the problems we have, they solve them really well. And so the panelists you've heard from here, that's what they do. And they present this stuff to us that is super reliable, and it works. Now, out of the gate, sometimes beta versions are a little scary. But we've gotten to the point now in broadcast engineering that it's more about software updates and network connectivity and making sure interoperability is solid and reliable. That's the key. And once we get past those hurdles, the familiarity and the comfort zone just gets better and better. So we're on a journey. The destination is going to be there, as Greg said. It's going to happen. It is happening, and we're on the way.
Well, we appreciate you sharing your expertise, and let me just ask you in 15 seconds each or so for either a closing thought or some takeaway message that you'd like people to leave this conversation with. And Greg, I'll start with you.
Sure. I think I said it already. I'd like to emphasize that this move to virtualization is really best practice. It's not a fad. It's not some headline or something, and it's about delivering the best service to our customers.
Alan Jurison?
No, I think that is exactly right. We need to make sure that we implement these new technologies in a very good, reliable way. I think using a combination of cloud-based resources and also hardware-based resources that are dedicated purpose, that are embedded appliances, really is our future. And that's the way to kind of get the best of both worlds, make things very reliable, but also very flexible. And that's where the industry needs to be.
How about you, Philippe?
Well, we've been at it for 30 years, and our aim is to get the engineer back to a full night of sleep without bad news in the morning that they have to rush to solve. So virtualization is really a way to get everyone there. And believe me, this is peace of mind, and this is peace in your household. Long life, married for a long time, and less problem if you virtualize everything.
It sounds like the cure-all for everything and solves the pandemic at that. Raj, you get the last word.
Yeah, just real quick, I would only recommend replace fear with interest and excitement. Get under the covers, talk to the manufacturers, the solution providers, and understand the benefits. I think it's been identified and explained here fairly well in a very high level point of way, but you really need to get under the covers and don't be afraid, just capture it and start being a business partner to your organization to provide these solutions that are reliable and financially prudent.
Well, I know the manufacturers on this call would welcome anyone reaching out to them for questions, and I'm sure that you guys on the NAB Radio Technology Committee are, always looking for people who are interested in stepping up and participating or expressing interest. So we'll continue to cover what you're doing in radio world. Gentlemen, I appreciate you, and for our viewers, if you have questions for our speakers, just email me at radioworld@futurenet.com, and I'll pass them along. We have several more sessions in the radio track for you today. And if you're watching this live on April 1st, be sure please to visit and chat with our exhibitors in the virtual exhibit hall. Thanks for joining us.